involved with us. They get hands-on. They are hands-on. If somebody wants a job, they hands-on. They get into the problem and try to solve, rather than giving the problem to the students. If you try to train them this way, they can beat any exam. Exam writing or clearing an exam. See, digitalization. See, next slide, please. Give me that. See, what is new? Is it internet is new? Is internet new? It is about 56 years old. If you think personal computers are new, it is 44 years old. If anybody say web is new, it is about 35 years old. Industrial robot, 64 years old. Talk about wireless, it is 25 years old. Artificial intelligence, 82 years old. That is one of the oldest systems. In fact, I did my PhD in artificial intelligence about 36 years ago. 36 years ago, I did my PhD here. And so, it is not new. You know, you think additive printing is new? It is old. Again, it's about 40 years old. We talk about the Internet of Things. Coke machine was applied IoT in 1980s at the Carnegie Mellon University. Again, 45 years old. So, when all these are old, what is new? That is the important point that we have to go through. What happened in the last 40, 50 years? We have reduced pricing by about 1,000 times reduction, and the cost reduction has come down. Computer sense as well as then speed is about again 1,000 times. Then memory it's about 100,000 times. And if you look at the global friendly, consumer friendly access, today you get your most sophisticated equipment just on a throwaway price. You know, in my days, we used to work on a computer. At IIT Bombay, we had a computer called IBM 1401. IBM 1401, the main memory, you know what? 14 KB. We worked on 14 KB. What all we do is, we will try to crunch our program within that, and we will try to do it. We use a card reader to just crunch the code, and then only we give the problem to be solved. So complex it was. So now, so if you look at the evolution, if you look at the first evolution of industry was your steam engines. Steam was the first evolution. Steam engines have been used, and even for all applications, locomotives, cars, everything tried to move on steam. That was mechanical production. They were trying to do more of. Before that, there is no automation. Automation starts only 1784. So all we know in the last is about 350 years. We know about all this modernization has happened. Until such time, we were trying to do handheld devices, trying to build something easy to work and so on. Then comes electrical engineering, which was 1870. Electrical engines were first where they implemented. It's Cincinnati slaughterhouse. First electrical machine engine was, they tried to test it on a Cincinnati slaughterhouse. So it was a slaughter place where they cut slot and they started moving. So that is where they have come into the division of labor, engineer, non-engineer. This. Then comes your electronics and IT. It is 1969. See the kind of machines, everything came in 1969. So the whole computing, whatever I talked about, everything starts from 1969. So from 69, we have everything in place. So Industry 3.0 started from it. Then where is the hitch? Hitch is on the computing part. Let me explain to you a problem. I did the factorization problem for solving my PhD thesis, which I wrote it in mathematics. And this I did in 89, but for my program to execute, I have to wait till 1998. 98 is about 9 years of waiting. I am able to run one set of program, but I completed in 2007. So many years of waiting because computers were not powerful. So that was the main thing. Then comes your Industry 4.0. 4.0 is nothing but digitalization. We have introduced digital manufacturing. What is digitalization and how it is different from normal computing? Digitalization is largely used for making a process without human intervention. It takes an action by itself. You need not have a human being to go and try to involve, and it runs on its own. And then comes your Industry 5.0, which is for mass personalization. It becomes more personalized way of working. And 5.0 is largely focused on sustainability. So what every action that you do on automation should be around sustainability. That was the goal of the 5.0. So there are 5 stages of disruption I have seen. There are disruptions I have seen. The first disruption was Kodak. See, when we all started our life in US, Kodak was a company which was a great company. Everybody praised about it. But nobody can beat it because they have the chemical. They built the chemical and they make the films and they can only make photographs. Anybody wants to make photographs, they got to get the chemical out of Kodak. Kodak was a Fortune 100 company doing extremely well. Suddenly they collapsed. Then we realized they have not adapted to digitalization. They have not moved into the automation cycle at all. So they stayed in that. So what happened? Kodak fell through. That was the first disruption I've seen. Second disruption is your internet. In 2000s, I see people were drawing long lines of wires everywhere. And I used to wonder why the hell they should do it, why they disrupt road. Now your metro work is taking the roads. Similarly, those days, taking the roads. But then we found the world become connected. We started getting connected to the whole world. We know a news today what Trump speaks before Americans knows we know. If he gives a late night speech here in India we know. But we are connected to the whole world. We all know when Iran bombing happened, what kind of bomb it was and how it is, whether it is penetrated, everybody knows. So that details start moving because of internet infrastructure. Then comes your disruptive business is your Uber. Uber, they introduced one fine day, the whole cars disappeared, car companies disappeared, travel companies disappeared, and they came in and captured a very huge market. It became rather a simple program. Without owning a car, they were doing the whole world has been using it. That was the disruption. Then comes your IoT and artificial intelligence. What happened? The industrial Internet of Things came into existence. What happened? It disrupted the entire thing because we started to realize temperatures those days, when I know, there will be people going and recording the temperature, coming back and feeding into the computer, the whole world knows. Now you have a sensor, that sensor read it, and every hourly we get the temperature, we get the rainfall, we get a host of data. See, actually, if in short, you all know, internet is connecting to your Internet of Things is rather connecting to an internet, a physical system, and then getting back into your data analytics. So that becomes a major thing. Then the adaptation curve. The adaptation curve, when we start looking at it, there was a time to adapt a computer, or let's say power steering, which was adapted, which was found in 1950, but power steering to come into existence, it took about 19 80. 1950 they found, 1980, 30 long years for them to stabilize power sphere. Whereas if you see your smartphone, it was found and got into the market within 6 months across the world. So adaptability starts growing. Why adaptability has grown? It's all because of digital media. See, digital actually brings the adaptation very fast. What we speak today, it gets connected. What we think today, it gets connected. What we foresee today, it gets connected. So that was the greatest point. After that, I would like to touch upon all this Industry 5.0. Cyber physical system, we connect with the cognitive sense. What is cognitive intelligence? You all know, right? So cognitive intelligence is the intellect, which is the intellect of your brain. And if you are trying to simulate or transform this intellect into a working program, then it becomes cognitive sense. What it does is your deep learning. That's why the deep learning comes. After you analysis is done, the huge data you get, and the data goes into the processing. That becomes machine learning. Then comes your deep learning. So the deep learning is where the cognitive connectivity comes. So what is that here? We are trying to build a cognitive sense to everything what we do. Best example would be your edge device. So edge device is a device which works without connecting to the world. It works by itself and it takes decision and moves things. So that is the beauty of that. So cognitive systems. Then the green manufacturing, zero carbon. So everybody moves on to zero carbon. See, carbon footprints become a great area to explore. If you are able to do a program for track and trace for carbon sequestration, it would be a great venture. I think mechanical engineers should think about carbon sequestration, which is going to be the big area to explore in the country, in the world, because we are becoming more polluting. We are polluting the world. See, we are able to protect ourselves, but we are not able to protect the rest of the lives. So now there will be a lot of sense to protect the rest of the life, apart from protecting you. So that's going to be the area. Then the cultural collaboration. See, what happens when you are trying to connect the world? There is the way of working by a German and way of working by a Japanese, the way of working by a Korean, way of working by a Chinese, way of working by an Indian is not the same. Different cultural. So cultural collaboration is key for Industry 5.0. Then the mass customization. You put everything, every customer decides and takes the material accordingly. See, even the supply chain, if you see, at the end point, you have an additive printer which prints the design and you hand it over to them if you want to make a customized shoe. It is not shipped from the factory. It takes a long time. It is in a different geographical location. They will keep an additive printer and move the design into this machine and will print and give it out. So the way customization goes from a simple manufacturing standpoint to a larger deviation. The trends that shapes the industry and business, innovation for productivity, smart ground exploitation. So you have to really become more innovative. So innovation is the key word for across the world. So a technologist is expected to do innovation. They can't innovate. They have to drive the innovation. And then emission reduction, which is the carbon footprint, which is the most important thing in any manufacturing. By 2050, no hospital should bring zero emission. Hospitals, all the health institutions should go zero emission. You don't have to ask about industry. Industry also has been forced to do that. And these protocols are slowly being pushed. If you are not doing your goals are not being met, you can't be in the international export. Your product will be rejected. So lots of pressure the world is going to experience. So we need to do a lot of work around it. Then operability, durability, and system versatility. You see the gear. If you look at the gear, what we use in a Toyota vehicle, it can function and it's a zero defect. Have you ever seen a recent vehicles, maybe about last 30 years, any gearbox fail? Never fail. Never fail. So zero defect they are able to do it. So that is the kind of operability, durability you got to ensure in your product. And that is the manufacturing. Host of manufacturing, this is the basics that they got to do. And engineering disciplines, design groundbreaking heavy machineries. So heavy machineries which can be manufactured smartly. Smart manufacturing helps a great deal to produce heavy machinery. That is the current trend for the industry. And this is what the principal also was mentioning about cipher physical system. So this is the computational method. You got to definitely, this is what we call it a digital twin. You got to have a cyber physical system. So a physical system should be connected to the internet space. So you have to have any change on your virtual machine, it should get reflected in the production and the productivity or the operability of a system should get reflected. So what you do here, that's a virtual system, and that virtual system, when you are trying to work on the physical system, will keep reacting to it. So that is the kind of designs people are doing. It's not the question of, see, we have implemented in Ford and Renault Nissan. Renault Nissan is doing a lot of work. I have seen their plant completely driven by robots, smart manufacturing, and they have a fantastic cyber physical system. So it gets executed and gets reflected on the manufacturing. So what you do it on the cyber physical system, for cyber system, it gets reflected in the physical system. So that is the trend which is going on. There are 6 principles which are design principles. Interoperability, ability of cyber physical system. This is the most important things for humans and smart factories to connect. See, the whole point is you are establishing a smart factory. I have seen smart factories in Germany. They just come in the morning. One person, he just gets the order. You have to make 500 GLC model, a car, GLC 200, 4MATIC, 500 numbers. Just key in the number, okay? The plant immediately checks the entire godowns whether the supply is in store. Then it works on, in case if something is lagging, it has to work on bringing them while the plant is on. So they have different method of supply chain. Urgent, immediate, which means immediately the supplier will be called and they have to transport within the time they get this manufacturing. So that is interoperability. So the communication, everything, it takes automated. So the moment they know what to be done, it gets automated and it starts flowing. Then the virtualization. See, virtualization is what I've been talking about. Sensor data and complete model is get simulated on a virtual platform. Once it is tested and we found everything, see, the best is the vibrational analysis of an aircraft. See what happens, the vibration goes high. In an aircraft, sustainability will be less. It may take a break. So while on the floor, if anything happens, they can do it. So we do the virtualization. That's through the simulation. Then decentralization. It's not something that everything is centralized everywhere. That's what just-in-time works. Various method of supply chain, etc. Then comes real-time capability. So the entire data starts flowing into the system. Once the data is there, it decides accordingly. I built a health application called DNMS in 194. I've automated the entire pattern of working based on what they get from the data. So once the data starts flowing, it will reverse the consumption pattern, it will issue the drug to hospitals accordingly. Every mode of things decides based on what I customize. So it goes automated. Today it is all artificial. It takes its own call and it decides. Like edge device, various applications, it does automate by itself. So when the service orientation, offering of service, cyber physical system, humans in smart factories, everything it gets handled through Internet of Things. So today, where all they have kept device, we don't know. See, now last time I went for a visit. I landed at the airport, and along with a few other people, we are going to Japan. We were going to solve a problem for the prince. She has an issue, so we are doing certain analytics work and the biotechnology work, and we are also building a precision medicine. We all came from the US. The moment we got on from the aircraft, we got a special vehicle. When we got into the special vehicle, that has got a sensor which absorbed who we are, checked the internet, and updated the database. By then I got down, the place where we have given a stay, and it welcomes, the system welcomes. Yes, Dr. Armukam, how are you? Hope your flights are operating. How long? I understand you're going to stay for a week, and we have got this room for you. And is it comfortable or not? Immediately they have given me a pod. They asked me whether you can load it onto your mobile or you can carry a pod. I prefer a pod because I don't want to load another unnecessary things. So I have taken a pod, and the pod directs everything. No human being. We just landed out of the car, we got checked in, had our thing, and the dietary time, what diet we want, we can program everything. Accordingly, foods, everything was supplied by the aegis of the King of Japan. Then we went off to work, and my preference of computer, my preference of gadgets, it decides by itself. The computer decides by itself. And the whole system decides and starts floating the data. So we get everything organized by the system. And it's off the system and we are on the system. So completely we maneuvered the whole trip by automated system. So that is the kind of flexibility things have been moving. Even Korea, they have introduced like that. So Japan I have seen, but not in Western world. For that matter, Japan and Korea has advanced so much, and of course China. China is gone ahead of all of us. They are the most leading country in artificial intelligence. I got a mind-blowing experience. In fact, I did a PhD in '89. My friend Kai Lee, you must have known, is one of the greatest guys in AI. He wrote several books. And he studied from Carnegie Mellon. We both joined in the same lab to work. And he went to China. Today he's $20 million worth. I came to India. I have contributed a little for the country. That's it. So the way China has recognized, and they made him to decide AI. And he decided the landscape of AI for China. The country gave such a great option. So, the way they have grown all these years, even the war, we can't beat them. It is just a matter of time to close India for them. They are so powerful and their communication system exists everywhere. So that's digital twin. If you look at it, your product life cycle and factory plant life cycle, and we do the optimization. So on and the test